Okay, so we're looking at the next question. So if x squared plus mx plus m is a perfect square trinomial, which equation must be true? So it's giving us 4 options, and we're looking at a perfect square trinomial. So some background on what a perfect square trinomial is, so we can kind of just take some examples here. So a squared, let me just erase that real quick. So if we had a plus b squared, we would get a squared plus 2ab plus b squared. So this is a perfect square, and then trinomial just means the 3 terms here. We can also look at the opposite case, so a minus b also gives us a squared minus 2ab plus b squared. A simple way to calculate this is, so we know that the first term will be squared, so a, and we'll get this. Then we know the last term will be squared, so we'll get b squared. The middle term, you just take 2 times a times negative b, and you'll get the middle term. You can also just go through the long process of doing a minus b times itself and just factoring out and simplifying and adding like terms together. Okay, so we've gotten some background on the concept here. So we're given 4 options, and we need to see which one gives us such that we have x squared plus mx plus m. So this term and this term are equivalent. That's what we're looking for when we expand each option. So when we expand x minus 1 squared, x plus 1 squared, x plus 2 squared, and x plus 4 squared. So we know that x, let's just go through one by one. X minus 1 squared is equal to x squared, so the first term squared, and then minus 2 times x times 1, so minus 2x, and then the last term squared plus 1 squared, which is just 1. Okay, so we can right away see that option A is not correct because this term and this term are not equivalent. Okay, let's go through option B. X plus 1 squared is equal to, so the first term squared, x squared, and then 2 times x times 1, which would give us 2x. So in the first one we did 2 times x times negative 1, in the second one we'll do 2 times x times positive 1. So that's why we got a negative in the first and a positive in the second, and the last term would just be 1 squared. So just to give you a better description of why it's 2 times x times 1, we can just kind of expand it out the normal way, or the long process. So we can see that x plus 1 times x plus 1, so x times x is x squared, x times 1 is 1x, so it would just be x, and then 1 times x, so 1 times x is x, and then 1 times 1 is just 1. So you can see how it gives us the final. We're just using kind of a shortcut to get the middle term. Okay, so you can see that the 2 and the 1 are not equivalent, so it does not follow that format. Let's go through option C. So we have x plus 2 squared equals x squared plus 2 times 2 times x, so 4x, plus 2 squared. 2 squared is just 4. So we'll erase this. 4. So we can see that 4 and 4 are the same. So we can see that it follows this format, m and m. So m here must be equal to 4. So we'll say this is the correct one. And let's just do the last one to just double check that no other solution is correct. So we have x plus 4 squared equals x squared plus 2 times x times 4, which is 8x, plus 4 squared, which is 16. So here, 8 and 16 are not equivalent. Therefore, the correct option is C. So they give you here in their solution, the student gives the definition for the perfect square trinomial. They go through each step, so they say A is incorrect, say B is correct. So here where they get x squared plus 2x plus 1, so they get the same output as us, but for some reason they say it's true. And then C is not true, so C here is the correct answer, and the solution here provided is incorrect. So incorrect answer choice. The correct answer is C. Student follows correct process but misselects final answer.